This is 8.1, the central limit theorem. And the central limit theorem just says regardless of the shape of the underlying population, whether it's normal or skewed one way or the other, the sampling distribution of x bar, which is the mean, becomes approximately normal as the sample size n increases. So the mean, what it's saying is, no matter what it starts out as, if we increase the sample size, then it's going to go to a normal shape. It's basically the same thing that we have been doing. I'm not going to go over this because that's from 6.1 and I don't have that information in front of me. But it says if the population, that's population standard deviation, and the population mean, then the sampling mean, the means are the same for the population and for the sample, but the standard deviation is a little bit different, and that's the only thing that changes. You take the standard deviation and divide it by the square root of the sample size. And this is the only thing that we have to adjust from what we learned in 7.2 and 7.3. So here's a normal, IQ is a normal 100, mean of 100, standard deviation of 15. What would the values of the population of the sample mean and the standard deviation of the sample mean be? Well, we know that the population, that the mean does not change, so it's going to stay 100. But this is going to become the standard deviation divided by the square root of the sample, which is 5. This one, the mean would stay the same, but it would be the standard deviation divided by the square root of the population, which becomes 3. So you can see what happens is the larger the sample size, the smaller the standard deviation. And what that does is that makes the picture a little bit more normal if we drew our standard deviations. It's really hard to tell from these pictures, but what happens is this one gets really tall and this one just kind of stays spread out. Okay, so we come over here. Now this is a right skewed with a mean of 180 and a standard deviation of 45. What would the values of the sample mean and the sample standard deviation become? The sample mean stays the same. The standard deviation becomes the standard deviation divided by the square root of the sample, and that's 11.6. And this one, the sample stays the same, the mean stays the same, and the standard deviation is divided by the square root of the sample. So that's 6.4. So you can see, once again, when the sample size increases, the standard deviation decreases. So here, a plant magazine advertises that a certain type of flower has a population mean of 4.6 and a standard deviation, population standard deviation of 0.5. A local farmer is concerned that the growing conditions in his areas make plants shorter than they should be. Find the probability. Notice that this is a mean, this is a sample. So this one is normal. We're going to find the z-score of 4.2, which is 4.2 minus the mean, which is 4.6, and the standard deviation, which is 0.5. So it's 4.2 minus 4.6 divided by the standard deviation, and that gives us negative 0.8. So our z-score is negative 0.8. Negative is going to be on this side of the mean. It says less than, so we're talking this side. And we look that up and we find 0.2119, which is 21%. This one, we have to find the sample distribution, the standard of error for the sample distribution. So our mean is the same, 4.6, but our standard deviation has to be divided by our sample, which is the square root of 4. So 0.5 divided by square root of 4 is 0.25. So now we can find our z-score, which is 4.2 minus 4.6 minus the mean divided by 0.25, and that gives us negative 1.6. So that's going to be over here, and we're still talking less than. So that's 0.0548, which would be 5%. This one, it's a sample again, so our mean stays the same. Our standard deviation is divided by the square root of 9, which is 0.17. So that's, no, yes. So now we got to find the z-score, which is 4.2 minus 4.6 divided by 0.17, which gives us negative 2.4. So we're still talking less than, and this is 0.0082, which is 1%. Number 4. We will do number 4 in class together to make sure that everybody understands. Here is the answers if you want to practice them yourself and ask questions.